Calculate the frequency of the sound waves emitted by the siren as heard by the listener. Okay, now this is where we apply our equation. Frequency as heard by the listener is equal to the speed of sound plus or minus the speed of the listener, and the speed of sound plus or minus this, the source. You see, this is not a perfectly linear equation because of this plus or minus and because adding or subtracting things to the denominator and the numerator. But it's almost a linear equation, and so we can work these things out. And we know that it's not 100% accurate, but it does give us a pretty accurate kind of answer. All right, so there we've got it. Now, the frequency of the listener. The frequency of the sound waves emitted by the siren. Okay, so that's what we've got to do. The frequency as heard by the listener. So this is what we've got to work out. So we get this multiplied by the frequency that we've just worked out for the source, 1214,39. The speed of sound is 340 in both cases, 340. In this case, the listener is stationary, okay? The listener is stationary, and therefore V for the listener is equal to 0. Now we've got to work out, and this is where we do it by inspection. Plus and minus is going to, adding or subtracting the velocity of the sound is going to increase or decrease the size of the denominator of this fraction. Now, are we expecting the velocity, the frequency as heard by the listener to be greater than the frequency of the source or less? Well, we're expecting it to be greater. So therefore, we are going to subtract the 30 meters per second over here. We then get a calculation of 340 over 310 times 1214,39. Okay, and that then is going to give us a frequency of 1331,80 hertz. And that is the frequency that the listener will appear to hear.